Hi everyone, welcome to Unit 2.2a video lesson. This is day 1 of transformations. So I think some of this is going to be a review from Algebra 2, and a couple transformations may be brand new. Okay, so when we have a function and we add or subtract a k value onto the end, okay, this is going to move our graph up and down. Okay, so that is a vertical transformation. When we have a value on the inside of our function, okay, added or subtracted, this is going to move our function to the left and the right. Okay, now the thing before we go on, the thing we want to note is h is always the opposite okay, and if you're unfamiliar with that or you've forgotten what that means, we'll take a look at that when we get into some example problems. Okay, if there is a negative in front of the entire parent function, meaning it is multiplied by a -1, okay, the result is that the graph reflects over the x-axis. Okay, so 1 and 3 are both vertical transformations. And 2 is a horizontal. Okay, so these 3 you may already be familiar with. Okay, you might not be familiar with transformation number 4. So when the entire expression of x minus h on the inside of the function is being multiplied by a -1, the result is that the function is reflected over the y-axis. Okay, so you may not have seen this before. So this is another horizontal transformation. Okay, when the entire expression x minus h is multiplied by a non-zero number outside the parentheses, so meaning like we put a 2 in front, okay, this is going to vertically stretch or compress our function. So the stretch or compressed depends on what the actual value is. So if the value in front is greater than 1, that's going to stretch your function. If it is in between 0 and 1, so if it's a decimal or a fraction, that is going to compress. Okay, so stretch is going to make it taller, compress is going to make it shorter, and by extension, wider. Okay, and our last transformation, number 6, when we put a non-zero value inside our function, okay, this is going to horizontally stretch or compress. So a constant in the front of our function is a vertical stretch. A constant inside is a horizontal. Now, the difference here from the vertical, okay, is that it's going to be by the reciprocal value. So when the a value is greater than 1, this is going to horizontally compress by the reciprocal. So for example, if we had a 2x inside the function, okay, we're really looking at a 1/2. So numbers, the coefficient on the inside uses the reciprocal. Okay, so a 2x is really dealing with a 1/2, and a 1/2 is going to compress. Okay, remember fractions always compress. if the value inside the function is a fraction, if it's in between 0 and 1, this is actually going to stretch it. Okay, so if it's a 1/4 x on the inside of the function, we're really looking at a 4, and a whole number of 4 is going to stretch our function. This is going to be horizontally, however. Okay, so any transformations that happen inside the function, inside the parentheses, those are going to be horizontal. And anything that happens in the front or the back are going to be vertical transformations. All right, your head is probably spinning right now, so let's look at a couple of actual equations and describe the transformations that are happening. Okay, so if my parent function is y equals x squared, okay, and my new function is negative x minus 3 squared plus 5, I want to describe the transformations. So I always like to start on the inside, okay, and I go from the inside to the front to the back. Okay, and it's nice to start getting in the habit of this order now, because we're gonna have to follow this order in the future. All right, so on the inside of the function, this is where the h value lives. Okay, so this would be x minus h. And remember that the h value is always the opposite. So even though I'm looking at an x minus 3, x minus 3 really says that h equals a positive. Okay, so that is shifting this 3 units to the right. Okay, then I like to go to the front. So in the front of my function, do I see a coefficient? Do I see a negative? Because those are the two transformations that I'm looking for. And I see a negative. Okay, so a negative is going to reflect this function over the x-axis. Okay, that's just the rule of what a negative in front does. Next, I go to the back, and what value do I see in the back? I see a plus 5. So this is the k value, and this is going to shift my function up 5 units. Okay, so inside, front, back, those were the 3 transformations happening here. Okay, so now I have 2 absolute value of negative x plus 1. Okay, so the first thing we want to do, whenever there is a coefficient or a negative on the inside of our function, okay, we want to factor that out on the inside there. So if I take out the negative, okay, I'm looking at x minus 1. Okay, because that's going to change things, that negative on the inside. So that always has to be applied with a parenthesis. Okay, so using inside, front, back, if you want to pause your video and try and write down your transformations, I highly recommend that. Okay, and then press play and check what you have. Okay, so the first thing I see is this has been vertically stretched by a factor of 2. Okay, there's a coefficient on the outside. Okay. Okay, so on the inside, I'm actually going to change this. Okay, this has been shifted to the right 1 unit. So let's talk about that. So we factored out that negative. Okay, and when I look at the x minus 1, this is really telling me that h is a positive. Okay, so a positive h is moving this to the right 1 unit. Okay, this negative here is what's going to reflect, and it's reflecting it over the y-axis. Okay, so again, if you want to pause your video, write down your transformations and then come back to it. So another thing that I like to do is write down what my A, H, and K values are, and sometimes I find that that really helps me to write out my transformations. So I see I have an A value of -1, I have an H of 3, and I have a K of -1. Okay, so this is shifting 3 units to the right. It's reflecting over the x-axis because the negative is in front of the function. And then it's shifting down 1 unit because it's minus k. Okay, so these transformations can definitely be tricky. You want to make sure that you are doing them in the correct order. Okay, and like I said, I really highly recommend writing down your A, H, and K before you try and write out what your transformations are. Okay, so now what we want to do is transform our table of values. Okay, so again, I'm looking at this equation and I'm going to first, write out what my transformations are. So I see that H equals -2. Okay, so this is shifted to the left 2. And then I see that K equals -4. So this is shifted down 4. Okay, so when transforming my table of values, we always start with the parent using x and y. Okay, so the parent here, if we remember from our 12 basic functions, the parent is just the absolute value of x. And the table for that is going to go -2 to +2. Okay, and then as I move out into my columns, I'm going to apply any transformations that I have. So shifting this 2 units to the left is going to affect my x coordinate. And shifting it down 4 is going to affect my y. Okay, so on the x side of my table, I'm going to have a column where I subtract 2. And on the y side, I'm going to have a column where I subtract 4. Okay, so this is allowing me to transform all of my points very easily. Okay, so I've applied the transformations. So now the 2 outside columns are the ones that I'm going to graph. Okay, and that's going to transform my function. Okay, and my parent would have been here. Okay, so you can see we've shifted down 4 units and to the left 2. Okay, so you are going to be asked to create this transformed table of values. Okay, that's how you're going to graph these functions since this is a no grapher unit. Okay, so let's try another one. So this is a quadratic function. Okay, inside I see an h of -2. So this is shifted left 2 units. In the front, there's an a of 3. So this is vertically stretched by 3. And then I have a k of -1. So this is shifted down 1 unit. Okay, and the parent here is going going to be y equals x squared. Okay, so when I make my transformed table of values, we're going to use the parent function to get my x and y. So the parent of a quadratic starts -2 to +2. Okay, and then I'm going to have columns for my transformations. So H is a horizontal transformation that affects the x, and the other two, A and K, those are vertical. Remember, I said anything on the outside of the parentheses is vertical. And we're doing inside, front, back. So the order matters. So if we do the front first, we first want to multiply by 3, and then we want to subtract 1. Okay, so I'm applying that to my x values, and then to my y's, I'm going to multiply by 3, and then subtract 1. Okay, so I'm not going to be able to fit the 11 on my graph, but I can do the others when I plot. Okay, so we know this is a parabola. Okay, and if the parent was here in blue, okay, we can very clearly see that our graph is much skinnier because it's been stretched so much that these top 2 points are not even on my graph anymore. Okay, it's moved to the left 2 and down 1, which is what we had said in our transformation section. Okay, so our graph matches what we found algebraically. Okay, we'll do one more. So a square root function. Okay, so inside, I have an a value. Okay, so I see that it's 1/5, but remember on the inside, we really use the reciprocal. So I'm looking at a 5. Okay, so this is going to horizontally stretch by 5. Okay, in front, I have an a as well of -1. Okay, so this is going to reflect over the x-axis. And then I see k equals 1. So this is shifted up 1 unit. All right, and let's see if we can squeeze our table of values in here. All right, so for a square root function, the parent equation is y equals square root of x. So remember, when taking the square root, we can't use negatives. And to make our life easier, I'm going to use all perfect squares in my parent function. Okay, so those are my parent values. And now I'm going to do my transformations. So the a on the inside, okay, the reciprocal of 5, that's a horizontal transformation. So I'm going to multiply my x values by 5. And the a that's in front is a vertical. So I'm going to multiply my y's by -1. And remember, you always want to do inside, front, back, and have it in the correct order so that on the y side, you are multiplying by a before you add your k value. Okay, so that would change your table if you did it in the wrong order. It's like order of operations for functions. Okay, so my new x values become 0, 5, 20, and 45. Okay, and my y values. So not very many of these are going to fit. Okay, I can actually only do about 2 points. So it's 0, 1, and 5, 0. So those are really the only things that I can graph here. All right, but it is a square root function, so it's going to keep going to the right. Okay, and if I graph, let's see, I can do some more of the parent function. So 0, 0, 1, 1, and 4, 2. All right, so this was the blue was the parent function. Okay, so we can see how it has changed. Okay, it's been reflected, it's been shifted up, and it's been horizontally stretched, which means it's kind of flattening it out. Okay, which is why not a whole lot of it fits on our graph. Okay, so that was everything for day 1 of transformation. So this is really just looking from the parent to a new function and identifying what the transformations are. Okay, so you want to make sure that we can write out those transformations in words and that you can apply them to the table of values.